We have three equations. You could solve them as a system of three variables if you want. You'll get the same answer as what we're about to get here. Or we could do it using matrices. So what you do with matrices, you put the coefficients of the similar variables on top of each other in a column. So 5 is the coefficient of B in this equation. The second column will be the coefficients of C, and then we got negative 10 for D. And usually we put a vertical bar to show that this side is equal to this side. Do the same thing with this equation, negative 4, negative 7, 38, 235, and then we've got 3, 7, negative 14, and then negative 98. So to solve this system using Gaussian elimination, that means we're going to combine these rows either by adding the rows together, by swapping the rows, or by multiplying an entire row by one number, by a scalar. And so right now I'm looking at this row and I'm thinking if I was to add the row directly below it, I would get a 1 here. And sorry, that's the big goal, is that you want to have 1 going diagonally, a 1 here, a 1 here, and a 1 here. And then you want to have zeros really elsewhere would be ideal, zeros everywhere else. Then we could just say, hey, this D column, D equals blah, blah, blah here. Okay. But usually you have enough information to solve. If this is like a 7 and this is a 3 and this is a 4, you just want diagonals here, diagonal ones here, and then zeros to the left of them. So that's the goal we're looking for. So that's why I'm looking at these two rows. And since adding two rows together is a tool in my tool belt, I forget the notation. I think they do something like this. I'm doing row 1 plus row 2. That's just a note for me to remember what I'm doing in this next step. A good practice is to only change one row at a time. So I wrote this next to row 1, and I'm changing it by adding row 2 to it. 5 plus negative 4 makes 1. 15 plus negative 7 makes 8. 38 plus negative 10 makes 28. And then 235 plus negative 100 is 135. Every other row stayed the same. Okay, so we got a 1 in the top left corner. We want 1s here and 1s here. The way you're going to make that happen is by starting off by making zeros down that first column all the way to the left. So my next operation is I'm going to take, let's see, I want to make this be a 0. So I'm going to say I'm going to take row 2. I'm going to add 4 times everything in row 1. I don't care what happens with these numbers. I'm just focused on my goal, getting a 1 on the diagonal and then zeros everywhere else in the column. So if I was to take this row 2 number and add 4 times row 1, it's going to make 0. Right, and so that's the idea behind starting with the 1 in your column, because then you've got something that makes it really easy to change everything else. So the top row stays the same. And then the middle row is the one that's changing. 4 times 1 is 4. 4 plus negative 4 makes 0. 4 times 8 is 32. 32 plus negative 7. I mess up this arithmetic sometimes when I'm making a video. So that would be awful because you have to go back and search through so many steps. Okay, so 28 times 4 is 112. 112 plus 38 is 150. And then we're doing 4 times row 1, so 4 times 135 plus 235 makes 775. And then you only change one row at a time, so this stays the same. And again, my goal is to make zeros elsewhere in this column, so I'm going to take row 3, I'm going to add negative 3 times row 1. Okay, everything else stays the same. Except for row 3. So I've got negative 3 times 1 is negative 3. Negative 3 plus 3 is 0. Negative 3 times 8 is negative 24. Negative 24 plus 7. I'm going to double check. Negative 24 plus 7 is negative 17. Yeah. Okay. And then I'm not going to do this in my head. Negative 3 times 28 is negative 84. Negative 84 plus negative 14 is negative 98. And I got negative 3 times negative 135 plus negative 98 makes negative 503 in the bottom. First column's done. Now we want to focus on getting that pivot, making this be a 1. So one thing you can do is we've been combining two different rows, but remember another tool in our tool belt is to take a row and just multiply by a scalar. So I'm going to multiply by 1 over 25, or in other words, I'm going to divide every element in this row by 25, just because of the way they set up the problem for us. Oh, that's not going to work. So this is 1, I don't know, 6, right? 150 divided by 25. And then 775 divided by 25 is 31. Everything else stays the same. Remember, for row reduced echelon form, we want to make this be a 0, because everything to the left of our 1s is eventually going to be a 0. I'm going to change row 3, add 17 times row 2 to it. 17 times 1 is 17. Adding that makes that cancel out. So this is 0. 17 times 1 is 17. 17 plus negative 17 is 0, just like we wanted. 17 times 6, add that to the negative 98, makes 4. And then we got 31 times 17, add that to the negative 503, makes 24. And we're almost done. We've almost got 1s across the diagonal. We just got to take row 3 and multiply by 1/4. In other words, divide it by 4. Zero, 0, 1. That's 6, right? 24 divided by 6. 24 divided by 4. Yeah, okay. So what we just found out was that our third column was the letter D coefficients, right? So that means D equals 6. You could keep going and make all these be zeros using these methods. That's using Gaussian elimination to put it in row reduced echelon form. But you really don't have to do that, because now that you know D is 6, that's going to unlock everything else. C was this column. This equation says 1C plus 6D equals 31. Well, since we know that C is 6, we can plug that in for D and solve. So that's 36 subtracted, so 31 subtracted by 36, yeah. Negative 5 is C. And you can take both those and plug it into the top equation. The top equation says 1B plus 8C plus 28D equals 135. So to find the final answer, you plug in negative 5 in for C, 6 in for D, and solve for B.